This is part 2 problem solving video lesson that contains the problems and solutions of the national examination for 2022. In part 1 you can get problems and the solutions of grade 9. This is part 2 which contains the portions of grade 10, so stay with me. What is the surface area of a sphere with radius 6 centimeter? Here we are asking the surface area of a sphere with radius 6 centimeters. So here we need to remember the formula for surface area of a sphere. AS is the surface area of a sphere and its formula is 4 pi r squared. So we have the radius, which is 6 centimeters, substitute here. So it becomes 4 pi times 6 centimeter square. The square of 6 is 36. 4 pi times 36 centimeter square. Multiply 36 by 4. The result is 144 pi centimeter square. Therefore, the surface area of a sphere with radius 6 centimeter is 144 pi centimeter square. The next problem is about right circular cone. If the volume of the right circular cone is 64 pi centimeter cube and the diameter of the base is 8 centimeter, so what is the height of the cone? So let us write the given information about the right circular cone first. So the volume of the right circular cone is 64 pi centimeter cube and the diameter is given. The diameter is 8 centimeter. If the diameter is 8, definitely the radius is 4 centimeter because radius is half of the diameter. So here we need to apply the formula for the volume of a right circular cone. The required thing is the height. So the volume of a right circular cone is 1/3 of the base area times h. But the base of a right circular cone is circular, therefore the formula becomes 1/3 pi r squared times h. So substitute everything here. So our volume of the circular cone is 1/3 of pi r squared h. Substitute here everything. We have volume of a cone, we have the radius. The only thing which is not known is h. So let's substitute. 64 pi centimeter cube is equals to 1/3 times pi r squared times h. So to avoid this fraction, multiply both sides by 3 so that we will get 3 times 64 pi centimeter cube is equals to 4 square is 16 pi centimeter square times h. Now divide both sides by 16 pi centimeter square by 16 pi centimeter square. So the h value becomes, now we can cancel this one, by 16 4 by 16 1. 3 times 4 is 12. Therefore the height of this right circular cone is 12 centimeter. The next problem is the application of trigonometry. Let me read first. The angle of depression of the top of the flagpole from the top of the building is 40 radical 3 meter away from the flagpole is 30 degree. If the height of the flagpole is 10 meter, what is the height of the building? So there are two things, the flagpole and the building. They are 40 root 3 meter away. They are this much distance apart. And the other thing is the angle of depression from the top of the building to the the top of the flagpole is 30 degree. So ideally the geometric representation of these word problems looks like this. So assume this is the building and this is the flagpole. So based on the information, the distance between the building and the flagpole is 40 root 3, and the angle of depression from the top of the building to the top of the flagpole is 30 degree. And the other information about these two objects is the height of the flagpole is given. So the height of the flagpole is given. So the required thing is we are asking the height of the building. So if the flagpole is 10 meter, definitely this distance will be 10 meter. Okay. So if we know the remaining portion, say this is h, small h. So if we know the value of h, we can calculate the whole length of the building. Assume for this diagrammatical representation, the whole building is 10 plus h. Now, if we know the value of small h, the height of the building can be completely determined. Therefore, since this is 40 root 3, this will be 40 root 3. And using the concept of geometry, these two are, if this is 30 degree, definitely this will be 30 degree. So apply trigonometric ratio. Now tan of 30 degree is equals to h over 40 root 3. But tan 30 degree is 1 over root 3, which is h over 40 root 3. Use crisscross, then h times root 3 is equals to 40 root 3, dividing both sides by root 3, we will get the value of h. So this is small h, so this h value becomes 40. Therefore, the height of the building is 40 plus 10. 40, if this is 40, this is 10. Therefore, the total height of the building becomes 40 plus 10, which is 50. So let's see the choice. So from the given alternative, the height of the building is 50 meters. The solution set of the equation given by the logarithm of x squared minus 3 is equals to 2 times logarithm of x minus 1 is how much? This is the question. So we will apply the property of logarithm to find the solution for this. So logarithm of x squared minus 3 is equals to 2 times logarithm of x minus 1 is the original problem. So this can be written as logarithm of x squared minus 3 is equals to logarithm of x minus 1 the whole square using the property of logarithm. You can take this value here. Therefore, by comparison, these two logarithms are the same, implies that x squared minus 3 is equals to x minus 1 the whole square. But x minus 1 the whole square means x squared minus 2x plus 1. So x squared minus 3 is equals to x squared minus 2x plus 1. So collecting like terms, we will get 2x is equals to 4. X squared can be eliminated. And rearranging the terms, we will get 2x is equals to 4. Dividing both sides by 2. The value of x becomes 2. Therefore, the solution set for this logarithm is 2. But we need to check by substituting into the original equation. Sometimes you may get invalid result due to the absence of the domain. So the solution for this problem is B. Next we have which one of the following is true about the trigonometric value of the given pairs of angles. We have a pairs of angles. So for each of these pairs of angles, let us see each of them separately. Tan of 75 degree is a positive angle, a positive quantity, and tan of 105. 105 is a second quadrant angle. In the second quadrant, tan is negative. Therefore, these two cannot be the same. One is positive, the other is negative. Sine of 75 is positive. All trigonometric values in the first quadrant are positive, but cosine of 105 is negative. So these two cannot be the same because one is positive, the other is negative. The other thing, cosine of 120 degree is negative. Cos in the second quadrant it's negative, but cos in the first quadrant it's positive. Still, this cannot be the same. The last one, sine of 120 degree. Actually, sine is positive in the second quadrant, and sine 60 is a first quadrant angle, which is positive. The other thing, the related angle for 120 degree is 60 degree. Therefore, sine 120 and sine 60 are the same. Therefore, the answer for this problem is D. Next, we do have quadratic inequality. Which one of the following interval is the solution set of the inequality? We have this inequality. Here, I will show you a very short and precise way of finding the solution for any quadratic and polynomial inequality. So, to solve x squared minus 5x plus 6 less than or equals to 0, first we need to write the factorized form. The factorized form is x minus 2 times x minus 3. Why? The two numbers whose sum minus 5, whose product positive 6 are minus 2 and minus 3. So the roots are positive 2 and positive 3. Okay, let us put these numbers in the line. Okay, usually most people solve this kind of quadratic inequality by using case method or sign chart method, but here I will construct a single line containing positive and negative signs. So since the leading coefficient is positive, I will start from positive, then negative, then positive. You always start from right to left. So this quadratic inequality is negative between 2 and 3. The solution set for this quadratic inequality is 2 up to 3. The next problem is coordinate geometry. What are the coordinates of the point that divides the line segment with endpoints P and Q? Okay, we do have a certain line segment with endpoints P and Q. Assume this is our line segment. Okay, say the point P is here. P is 0, 1, and Q is 5, 6. Okay, assume this is the endpoints of the line segment. Suppose the point that divides the given line segment, say point A is somewhere here with coordinate x0, y0. This point divides the segment in the ratio 2 to 3. So there is a formula to calculate this unknown segment. So call this is x1, say this is y1, say this is x2, y2. Let us give a letter for each. Say this is R, say this is S. So the unknown coordinate x0 can be calculated as x0 is equals to x1 times S plus x2 times R over R plus S. Okay, so based on this, substitute this variables. X1 is 0. 0 times S is 3, plus x2 is already 5 based on these notations, and R is 2 over R plus S. So 0 times 3 is 0, 5 times 2 is 10, 10 over 2 plus 3 is 5. So the x0 value is 2. the x0 value is 2. So let's calculate y0. Y0 can also be given as y1 times s plus y2 times r over r plus s. So this is y1 is 1 times 3 plus y2 is 6 and r is 2 over 2 plus 3. So 1 times 3, this is 3 and this is 12. So 3 plus 12 over 5, meaning that 15 over 5, which is 3. Therefore, the coordinates of the point that divides the line segment PQ in the ratio 2 to 3 is 2, 3. Therefore, the answer is A. Which one of the following trigonometric values is correct? So let us see each of them. Sine of negative 120 degree is the same as the negative of sine of 120 degree, because sine is an odd function. So this is equivalent to the negative of sine 60 degree, which is the negative of root 3 over 2. So this cannot be a correct statement about the trigonometric values. Let's check for B. Cosine of negative 120 degree is the same as cosine of 120 degree, because cosine is an even function, but cos 120 degree is negative of cos 60 degree, because cosine in the second quadrant is negative, but cos 60 is 0.5, so this is negative 0.5. Therefore, the statement in B is correct. Let's check for C case. Tan of negative 120 degree is exactly the same as the negative of tan 120 degree, but tan 120 degree is the negative of tan 60 degree, which is equivalent to tan 60 degree. Therefore, this is radical 3. It's a positive value. So tan of negative 100 degree cannot be negative. The last one is cosine of the negative 60 degree is equivalent to cosine of 60 degree, which is 0.5. So still this is wrong. Therefore, the answer for this problem is B. What is the point of intersection of the median of triangle ABC, whose vertices are 0, 0, 6, 0, and 0, 4? So the vertices of triangle ABC are given, and we are asked the point of intersection of the median of triangle ABC. So ideally, the picture for this, look, one of the vertices at the origin, the other is on the positive y-axis, and the third one is on the positive x-axis. So ideally, the graph of or the diagrammatical representation of the triangle looks like this. Assume this is a triangle ABC. So based on the information that we have, one of the vertices at the origin, the other is on the positive x-axis, the third is on the positive y-axis. So here we are asked the point of intersection of the medians. Okay, assume these broken lines are the medians of a triangle. So we are asked the point in which the medians intersect. So we need to know some principles related with the medians of a triangle. We know that the medians of a triangle intersect at a point 2/3 of the distance from each vertex. So the distance, say this point is point O, where the points intersect. This point O contains the entries x0, y0. We are interested to calculate this x0, y0. This point is definitely the point where they intersect. The other principle or the other thing about the median is the medians bisect the opposite sides. So A up to C will have a median somewhere here. Call this point D. So this point D is a median for A and C. So its coordinate becomes 0, 2. And you can also give some point here E, but for now we don't need to know this E. So take this segment, the segment BD separately. So when we take the segment BD separately, we will have a certain line with endpoints, like we did before. We will have a certain line segment with endpoint 0, 2. The other endpoint is 6, 0. Say this is B. So somewhere we do have the point in which the medians intersect. Call it x naught, y naught. But by the theorems on the medians intersect at a point 2/3 of the distance from each vertex. So this point is a point that divides this segment in the ratio 2 to 1. So this is R. You can say this is S. Give a name for this coordinate, say x1, y1. Say this point is x2, y2. Therefore, we can easily calculate the point in which the medians intersect. So by the formula, x naught is the same as x1 times r plus x2 times y. X2 times s. This should be s over r plus s. So substitute here everything. x1 is 6 times r plus x2 is 0 times s over r plus s. So definitely this is 0. 6 times 1 is 6. 6 over 3 is 2. Our x naught is 2. And y naught is y1 times r plus y2 times s over r plus s. Okay, so substitute everything here. Our y1 for the time being it's 0 and r is 1 plus y2 is 2 and s is 2 over r plus s. So this becomes 0. 2 times 2 is 4 over 3. Therefore the point in which the medians intersect at a point is 2, 4 over 3. 2, 4 over 3 is the point in which the medians intersect. Therefore 2, 4 is here. Okay, so this will be our answer.